How's it, Jordan here? In this video, I'm going to show you how to make a neural network in Unity.
Gosh, okay. Well, for someone that doesn't understand neural networking or has had a tiny inkling of neural networking back 20 years ago when I read the book, what was it called?
Fuzzy Logic.
Fuzzy Logic, when I did my degree back in the old days. By the way, how are you enjoying that book?
Oh, it's quite interesting. I'm slowly going through it.
Good. Okay, so you're going to explain what the devil you've done, and you can show us what it looks like.
Okay.
That looks terribly boring. It looks like a 1990s website.
Yes.
It's been badly designed in HTML. Curse that HTML.
Right, so as you see here, we
No, all I see right now is Scooby-Doo.
Okay, wonderful. So you can change these values, and unlike the previous neural network, I'll give the
Okay, hold on. What is a
video.
neural network, first of all, for people that have no idea? What is a neural network? Why did you do this?
So a neural network is just a voting process where the inputs have some weights, and slowly the weights add up to from all the connectors, and they equal to the correct output. Well, as long as all the weights are correct.
Okay, but what has this got to do with a human brain? Because it's obviously based on the human brain, right?
A very loosely stringed to a human brain, yes.
I'm going to use a few puns here. Loosely coupled.
Yes, loosely coupled to a human brain with the neurons and the connectors kind of, if you look at a neuron in a brain, and a special microscope, I think someone did that, and you had a bunch of little like line thingies, but here's a very rough description of what that kind of would be like.
Okay, so this is a basic, very basic neural network. That you are. This is the baby's baby of AI system.
Yes, so there's a deep neural network, and that makes up things like OpenAI or Gemini or Bing, I think, the new Bing AI.
Okay, cool. So you're going to explain to us what this does, or the code, how much code it was. You're going to break up the code, explain it, and see if it actually works. Because
I show people how to make it step by step.
Okay, awesome. And not only that this is not just a fakery.
Yeah, it isn't just like a little diagram stuck on the screen here. No, well, it is a diagram stuck on the screen here, but it is simulated. So this neural network does have a weird little thing, but that has nothing to do with the program being incorrect. It's just a bit of weird thing. I counted up everything. It's all correct. It's just a weird piece of this particular neural network.
So this is your first attempt as a neural network. You haven't got a degree. This is something you just like pulled out of your thumb, or what? Or someone came.
Yeah, I got bored one day of every other mini projects I've had, and decided to try out neural networking. I wanted to make some text-based AI. I think we get into that in the neural networking video I'm watching.
So we had a discussion beforehand. What do you want to do with this? Do you think you could apply this to a game? What is your intention with neural networking?
I'm not sure. Maybe a special boss fight at the end, because I don't think, maybe it wouldn't be the fastest if you had tons of little, maybe you had animals running around, each had their neural network. I don't know if they'd be fast or not, if that would be okay.
So this is totally experimental. You don't know what the hell you're doing. You're just like, tempting.
Sort of know what I'm doing, but I don't know why I'd use it for. It's just quite interesting and
so you could apply this to something like a track or a car going around in circles, or
maybe, yeah. If I
how
can
would you
figure out how
envision
to train
this?
Stuff.
Use your neurons. How would you envision this? If you thought about it, how would you use this?
I'm not exactly sure. Maybe enemies learning from the players how they happen. I think with this one game, I don't know if it uses neural networking or not, probably not. But if later you snipe all the players in their head, right, all the enemies in their head, then they'll start wearing helmets the next day. If you always shoot kill them at nighttime, they start wearing night vision goggles. I quite like that concept.
Okay.
Manual networking would be good for that, I'm not sure.
Okay, cool. So let's see this is not fakery and you could actually...
Yes. So if it is a bit weird where if one value is on or it can't figure out which one, it just kind of says that it's solid, vertical, diagonal, and horizontal, which is a bit odd, but that can't really be fixed. But let's say we make this a horizontal. Okay, so this, if we mapped it out on a little 4x4 grid, this would be a horizontal line.
So you
And
know
it
what
says it's
horizontal means? It's a tabletop, right?
Yes, obviously.
Okay,
You get the
good.
2 black, which is the bottom 2 pixels, and the 2 white, which are the top white pixels. And of course, it doesn't matter if you switch it up, and the black is at the top and the white is at the bottom. Doesn't really matter. It will still say it's horizontal because these inverters are here.
Okay, cool. So, how did we spoke about the sticky parts? You mentioned sticky or some glue, which I brought into the fold because back in the day, Black Magic was DNS 20 years ago, and they would say some glue aspects of how the friendly name connects to the IP address. You'd have some glues. What's the glue that's connecting?
Well, you nearly got it right there. It's all the connectors.
Okay,
All
good.
these parts, all they do, their most important part, the whole network, these are just like integers nearly, with a little circle attached to them. But all these are they just, these are the most important parts. These are the connectors, they each have weights on them, and it gets the start connector's weight, which is -1, times it by its weight, which is 1, and it gets 1, not 0. The reason why there's 0 is because it adds all of the connectors it has up. So this is 1 times by 1, which is -1 plus by 1 is 0. That's how I got 0. And it does that for every single connector, adds them up. And to make sure they don't get out of control and big, I think usually use a sig function or a sigmoid function. But here I'm doing mathf.clamp. The reason why is because between -1 and 1. The reason why is because that in this example they seem to be using clamp, even though they say they're using sigmoid.
Okay, so you're saying that they're not doing that. So you got inspiration from a visual concept and you've duplicated using it programmatically, doing it programmatically. So
Yes.
this is your attempt of their practical or visual example. Okay, cool.
Yeah,
Cool.
and implementing a visual example is to go along with it.
Okay,
Which
cool.
of course you can remove very easily just by deleting a few variables in here.
Okay, so can we look at, is it actually work? And you showed us that it does kind of work.
Yes, so let's say we want a diagonal line, which is top left is 1, top right is -1, and bottom left is 1, bottom right is -1. That's all normal, and that's mapping is the same throughout the whole thing, neural network. It says diagonal. If we make it vertical, which I think it's something, not that. No, how do you make a vertical? Is it something? Yes, vertical. There we go. So now it thinks it's a vertical, which it is, and it says vertical. Even if we invert all the values, as I said, and don't get them precisely lined up, so it's like that, it still says it's vertical, although it does think it might be diagonal or horizontal a bit.
Okay, interesting. Lost me, but interesting. Are you going to explain the code and how you done it? How long it took you to do? How long did it take you to do this or implement it?
I don't know, maybe less than a week. I started pretty much exactly after I've done the intro video I started on this project. So
Okay.
maybe 3, 4, 5 days, I'm not sure.
Okay, cool. Okay, so let's have a look at the code and see what that looks like. It's probably
Yep.
it's probably millions of lines of code.
Yes, 272 lines of code actually.
Wow, that's amazing.
Yeah. I don't know if more lines of code is good or not.
That's actually very, very small.
Well, yeah, I guess it is. I mean,
That's well done.
neural networking. Well, it is quite simple, but as you see here, So I think in real neural networking, you wouldn't have to have so many initializers, because like the first, what?
Because you're presenting it,
100.
you're doing it visually. You wouldn't have to do it visually normally.
Well,
But you,
this is necessary, but I think normally you have every neuron connect to every other neuron in the next layer. In this, I have to set each connector neuron properly. You can add it so it does it more dynamically, but I'm doing this because that's how the displayer did it. I want to.
but you
kind
wouldn't
of
have to
copy
have a
it.
display in the real pro. This
Well,
is
I
just
mean,
for
this is
the
how
project.
the video I was watching from did the view. They
Yes.
removed some, and I think that was because their weight was 0. But I've done it all now, and if you want to make everything connect up to everything else, then you can.
Okay, so explain it to us then.
So first, I'm just initializing all the input neurons. I'm giving them a position in the world. So there's a layer position, and this is the neuron, and there's a neuron position. So the reason why I'm doing this is just because this is for the displayer.
Yeah.
So in reality, you'd scrap pretty much all
Well, that's
of
what I
this,
said initially earlier.
except this boolean. So this boolean is on the output layer, right? You want to clamp it between, instead of -1 and 1, you clamp it between 0 and 1. And this is using, I think, a function called ReLU.
Can you
Yeah.
explain what ReLU is? Sounds
So
quite
instead of
fun.
using a normal clamping, which is what I'm doing, although I haven't given you a sigmoid function if you want it. Not sure how you'd use it though. It's a bit broken. I don't know how it works exactly.
Maybe next week.
Maybe, but it's just a clamping. It's a normal clamping, linear clamping. However, it blocks it between 0 and 1 instead of -1 and 1. And that's about it for ReLU. Then we have all the connectors. So this is all necessary, by the way. So this initializer, unless you're doing it a bit differently. So you have the input neuron, we're giving it the start neuron, it's connected to, and then it's connected to, again, the output, the end neuron. And then we give it a weight, which is its multiplying value. As I said earlier, you have the input neuron values times by -1 in this case, and then it's equal to processing neuron. You add that onto its value. And we just do that quite a lot for everything else. Here I'm just adding all the neurons to their layers. Thank goodness I don't have to add each connector to the layer, which I would have actually if I hadn't changed the system like 2 days ago. Glad I did. But we just have the input neurons, hidden layer 2, hidden layer 3, and output layer. So I believe this is called deep neural network because it has more than 3 layers. It actually has 5 layers. But here I'm just doing, I don't know if this is hacky or not, but I'm setting the inputs for everything on update just before I update the layers. And here I'm updating layers. I'm looping through every single layer, but I'm choosing the second layer. So I'm starting at layer index 1 instead of 0. And the reason why is because I want to look at all the connectors that are connected to that neuron. Instead of, because the input neurons, they can connect to as many neurons, connectors and neurons as they like. But the neuron at the second layer must be connected to all the input, must be connected to all the input neurons it's actually using. That caused huge problems. I spent hours just sitting there looking at code. But I fixed it, and in update layer, we're just resetting all these values. By the way, the neuron value here. And what's nice about this is it won't reset the input layer, which is just quite a nice little part of it, which accidental nice bits of it.
What do you mean accidental? What do you mean by that?
Well, it wasn't really my first intention, but then I just realized that it was a really nice way of doing it. Instead, before I had to have a complicated if statement. And I didn't like it. But then we have for each loop with a neuron, we loop all the neurons in there. We have a sum, and this is how much the neuron's value is. And we're looping through all the connectors connected to that neuron. We're getting the end neuron, so we're making sure it's actually connected to that neuron, and not it's starting at that. It's not starting there and ending somewhere else. And then we get the sum plus equals by connectors dot weight times by the connector dot start neuron dot value. And then at the end, after we've done looped through all the connectors, we just go neuron dot value is equal to sum. The reason why this capital V, by the way, is because I have two different things. I have value, and I have raw value, which and I have the value. So this value, this is the first time I've ever really done get and set. So I made, instead of having to do a whole mathf.clamp here, which is a bit irritating, and it wouldn't work with my use ReLU, I'd have to have a big if statement, which I don't like. Said if we receive it, we clamp it, and if it's use ReLU, then we go, if it's use ReLU, it's 0 starts, and else it's -1 starting. That's my nice little logic here. The first time I've also used this kind of if statement before.
Cool.
I'm only starting to use these two things now because I found out they're really useful. Then we have raw value.
It's like a candy store, isn't it?
I know, there's so many cool little things I've never really used before. I mean,
Because you never had the opportunity to use it. I mean...
Well, I saw them, I knew they were there, and I dismissed them, and because I thought the first time I saw them, they're a bit complicated.
So it must be awesome to be able to use something like, cool, some nice tooling.
I know, make it so much more simplified. It's wonderful.
And it also shortens it too.
Yeah, simplified. So
Yeah.
And the raw value, when we're saying it, we also clamp it using the same mathf function clamp. Then,
So what if someone comes up to you say, Jordan, you've done great work here, but it's totally all wrong? You'd be so excited, wouldn't you?
I would have to take this video down and redo all the code for the next
No,
few
no,
days.
no, you wouldn't take it down. You go, awesome, can you show me what I've done wrong? And you just leave this, and then you just do the next video, and you go, wow, this is a new improved version. People like to see mistakes, right? But it's more than likely not a
I
mistake.
don't know if
right?
people like to see mistakes where the whole program's incorrect, but I mean,
But you know what I mean, you
and
want to
then
learn,
start
right?
implementing to,
You want to learn, right?
yeah, but they kind of generally people want a tutorial that's correct. That's a general idea where the
Yeah, yeah.
person teaching you.
And this
knows
is all
more
your
than
code, yeah?
yes. I think Chat helped me with one function that got me started properly with everything else. We did this project 3 times, I think, the whole code base.
Yeah, and I mean, but you've written all this code yourself.
Yes.
Okay, cool. Go for it.
But yeah, then we have the neuron. So by the way, here I'm saying the renderer.value. So if we go to neuron renderer, this is just the renderer. It has a value. It has the value display, which is just a sprite renderer. And it has a bit of a hackly very quickly, not hackly, but I just quickly added this in about 5 seconds. When my dad said he really wanted to see like the value of it.
Yeah, okay. Yeah, no, I like value.
And I've also never really
Your dad,
used...
you mean me?
Yes, yes, you.
Cool.
And then I have the value text, value.text is equal to value.toString. I've also never really, I have used toString obviously, I had to, but I've never used with this where I can format it kind of. I really like this now. So I could make another decimal place in here. Which is quite nice to not have endless long values with like 0.0001.
I wanted to ask you something. You said you use chat, right? I mean, your experience using chat, I mean, I know that you get very frustrated because it's not very useful in some points. What are the useful?
It is very useful if I'm struggling with code or sometimes like I actually got chat to generate all of this because this is too painful for me to write. I'm not writing all this.
So it's the
by
dog
hand.
work, in other words.
Yes, or I have a problem that I spent 2 hours on and no one can figure it out.
Yeah.
But also recently, I was trying to render a face, but for some reason it was inverted and its texture was flipped upside down. So I chat, nope, couldn't figure it out. But I tried the Gemini, which I haven't really used before. It worked it out really quickly. It's really nice.
Cool. So what was the problem?
Well, I knew what the problem was. I just couldn't figure out how to solve it because I don't know how to do complex matrix rotations in my head.
Yeah. Why not? What's wrong with you? Okay, cool. So I mean, a lot of the times it can make the code very complicated, right? Or change the code where you can't actually understand it.
Yes, the biggest problem, I think, even if my code's a little inefficient, I don't want Chat to rechange the whole thing to make it more efficient because I won't understand the line of it,
Yeah.
which will make it really inefficient for me.
Yeah.
Yeah, it's always a problem because I understand my code way better when I've written most of it.
Yeah. But I mean, absolutely very useful for dog work.
Yeah, or problems I
Yeah.
can't figure out for like 2 hours. Yeah, it's just useful, just as a
Yeah.
little helper.
But I mean, having to write all that, that duplication that you said, that is
And
definitely
with these
something
tiny little values I
that
could
AI
get
can
wrong.
help. Yeah, absolutely. Because, yeah, that is just laborious.
Yes.
Okay, so what else? What is the ending part then?
Well, not much actually. We have the connector, but most of this code is rubbish. You could delete most of this really because it's all rendering stuff.
Yeah.
And I give the start neuron and Godot connections. I just give it nodes, so every other neuron knows its connectors here. And I set the weight and initializer, and I also have this. I don't know why I have this here. Why do I have this variable here? It should have been gone like days ago.
Okay.
That was an old variable I think that I forgot to delete. So what that was is originally I was making the connectors do everything. But the problem was they didn't know what the previous connector's value was, so end value. So it just kind of overrode it. And the end neuron of it, for some reason, wasn't the same neuron as the actual real end neuron. Oof, it was a pain. So every time I loop through a layer, I have to give it the previous neuron's end result value to it so it could plus it in here. But now that's all done and it's all plus now. So instead of the connector, those are just kind of variables, basically, special variables. Now everything and all the plussing is done here. And why do I have this big, long, horrible debug that's like...
No. What's interesting is you are not necessarily a maths expert.
Well, I know how to times and plus.
I mean,
that's all
so
you
that's
need.
what that's like grade 6 maths. So what's more important, mathematics or logic?
Well, it depends on what you're doing, but logic and programming mostly.
Yeah, so I mean, you don't even really have to understand maths. You have to understand basic fundamentals. So all those programmers out there going, oh, I don't know maths, I'm terrified about maths. Don't worry, it's logic. If you've got a great logical mind,
I mean, if you're doing ray tracing rendering, then you might need to know some maths, yes. But really depends on what you're doing, but generally I've got along without having to do complicated things much at all.
yeah. So all those people that just want to start out in programming, you don't really have to have a serious amount of maths, right?
Yeah, very occasionally there's some hectic maths, like the weird E signs and things like that I don't like very much, but
Because you're still learning about that.
yeah, I try to learn a bit
I mean,
of complicated
you
things
only
in maths.
you're 12 now. You're only doing Trig 10, grade 10, which is, I don't know what that is in other countries, but 2 more years to finishing school. But so that's not high-end maths or algebra.
Definitely not.
Cool. So what I'm trying to say is that you don't need high-end maths to be a good programmer. So there you go, guys and girls.
Yeah, just a general programming, you don't need to know any maths, yeah. You
Yeah,
need to
it's
know how
just-
to times and plus.
It's a different kind of brain logic, connecting things together.
Well, logic's definitely necessary, and connecting things is also quite necessary if you're doing neural networking.
Yes, I know. That's why I brought it in. Unlike me, loosely coupled brain. Anyways, how are you going to finish this off?
Well, I'm not sure. So I guess the last bit is just the instantiating, and what I'm doing is I have this nice little kind of microscopic little algorithm, because what I have to do is in a neuron initializing it, as you saw at the top, it inputted 3 variables, or sometimes 2, because I have this as a default value. So you don't need to initialize it if you don't want to, but I just give it a layer index, which is what layer displays in, and the height index, which is what height it displays in.
Okay.
And that's pretty much it, I think.
That's awesome. Let's see it again one more time. The Scooby-Doo,
Okay.
the cotton ball, or the
whatever you want to call it, I guess. Right, so let's just press play.
Okay, cool. So there you see everything on the left-hand side there. Gosh.
And this time it's obviously expandable, which is wonderful. Way better than the horrific mess that I'm ashamed of in the last video I showed off.
Well, it was the first attempt. You didn't even know what a neural network was.
Yeah, it was
a month ago. You never heard of a neural network. I mean, that's how bad it is.
Yeah, I never done neural networking before this.
Okay, that's great. That's very interesting. Congrats.
Yeah. And as you see, it can, even if they're different values, as in the last video, it can still figure out that it's solid, 100%.
It would be nice to write this in a different language that's maybe more keyed to...
Yeah, I was first doing Swift, but then I struggled hectically. The reason why is because even though Swift is perfect for this, right? The problem, and I love Swift and I know how to program beautifully, the problem is that it was hard for me to visualize and debug. There's a way easier way to debug if you see it. And you can obviously use SpriteKit, but I tried, it was just a bit of a pain. And
could you duplicate this in Swift now?
With the source code, yes, I can very easily just copy and change things to Swift.
And what other languages would you use? There's Java, would be interesting. Yeah.
I don't know about Java. I mean, I've done Java and it's a nice language, but Java is pretty similar to C#. Why don't you use Unity and C# for this, or just C#?
Yeah, absolutely.
But Swift would be my number one go-to.
And C++. That'd be a cool language to try.
Maybe
That's
C++, but I like Swift better because it has a full IDE. C++ does have the IDE on Xcode, but just like Swift better. It's just nice formatting, modern, unlike the ancient C++.
Yeah, don't say that to your to your gaming.
Yeah, with all the Unreal games there.
Yeah, cool. Okay, yeah, that looks really cool. Anyway,
I'm very happy with it, and I'll see you. Well, actually, I won't see you next video because.
So what are you going to do with this? What's the next thing you're going to do with this neural network? You're going to see if you can teach it, or you could do some basic
training, I guess. That's the next step. But yeah, without further ado, I guess let's start making this neural network in code. Okay, so first thing I'm going to do is choose 2D URP. I'm in Unity Hub now, by the way. So I'm going to change the project name and I'm going to make it neural network. Whoops. There we go. And I'm going to click create project now. And I'll just wait a bit for it to finish generating the project. Right, the Unity project has finished generating. I'm just going to make this project window a bit smaller. We are going to go, and it's actually all generated. So I'm going to go to main camera, and I'm going to change from this dark blue to a lighter blue. Let's say something like that. Let's say like a greeny color. Next thing I'm going to do is I'm going to go make a folder. Actually, I'm just going to add this Universal Render Pipeline Global Settings into Settings folder. And I'm going to make a new folder. I'm going to name this Scripts. And I'm going to make a C# script named Neural Network. Okay. And let's wait for it to generate. And if we just double click on this, it should open it in your favorite IDE. Right, so my script has finished generating and opening. So the first thing I'm going to do is I'm going to delete all the functions inside my neural network. So next what I'm going to do is I'm going to make a few new classes. I'm going to make a public class layer. I'm going to make another public class. Okay, and this class will be neuron, and the layer will be just a public list of neuron and neurons. equal to new list neuron. And if this loads and gives an error, then make sure you got system.collections.generic. And this is pretty much all we'll need. I think we'll need a system.link, I'm not sure. But keep in mind, these two are very necessary, otherwise you won't be able to have arrays or collections. So no lists. Then I'll have another public class, and this will be connector. So for the connector, it's going to have a few variables. It's going to have a public float, weight is equal to 0.0f, and that's it for now. What we're also going to do is for the, obviously it's not it, there's a lot more code for the connector, but that's it for now. I'm going then on the neuron, I am going to have a, the neuron is going to have a public float, you can just call this value. Okay, and then we're going to have a public float with a capital V value, and this will be our get and set variable, and we can make this a private float value. There we go. So we can get, and we can on get we can go return mathf dot clamp. Okay, this is going to make sure that it keeps our value in bounds, and we can input our value, and we can input -1f and 1f, and then we can add set, which will be doing quite a similar thing. It's just that in the top we'll have value is equal to mathf dot clamp value, and then we'll have -1f and 1f, and then that should be it. Next, I think we should focus on the actual renderer for this, just so you can visualize it better. So I'm going to have a, also by the way, let's just add a public, I'm going to have a public list of connectors, and we'll have connections is equal to new list connector. There we go. I'm not sure why it doesn't like what I've done here. Is there anything I've missed out? Oh yes, here. There we go. I forgot a comma, I replaced it with a full stop for some reason. Oh, and this has no semicolon. Right. So on the neuron, when we initialize this, we're going to go public neuron. This initializer runs only once when this is initialized, so when we create an instance of this neuron. And it's going to have a few different inputs. It's going to have an integer. This is layer pos, or let's say layer index. Layer index and height index. Okay, that's it for now. Obviously we have to add one or two, I think one more variable in here later on, but that's way later. We can go layer index, and this will, we can have a float actually. Let's add a float. So the xpos is left to right, and that will be the layer. So I found out the perfect amounts. The little algorithm for this is -8 plus by layer index times by 3. And that's it. And then for the y-pos, this is the actual position in the world of this neuron. It's not necessary for real functioning though in a neural network. And this will be 3 minus height index. There we go. And next I'm going to have a vector 2. And this will be position is equal to new vector 2. This will be xpos and ypos. And we can just make a little comment here. Let's say getting world position for neuron. Right. Next we can have another, we're going to have the actual initialization of the renderer. Instantiate neuron. We'll have a game object. and this will be neuron object is equal to game object dot instantiate. And if you haven't used game object or instantiate before and you just use instantiate, game object instantiate is part of mono behavior, I believe, and because we haven't inherited from mono behavior, because then we'd have to add it to an object, which would be a bit irritating. We can't really do that, so we have to go to game object or instantiate. So on this instantiate, we're going to do a thing called resources.load. It's a great way of getting objects from your assets folder. So I'll show you how you can actually use this in a bit. But we can just make a game object. We'll call this, so we're going to get the neuron object. And if you want, you can even go prefabs/neuron. Okay, and we need to give it a type. That's what kind of type it is. Is it a script? Is it an image? Whatever type it was converted to. We can then give it a position and quaternion dot identity. So I think that's it for now. Let's just actually just run it to see how it works. So what I'm going to do is go to neuron, and I'm going to have a start. So void start right here, and neuron is equal to new neuron. We're going to give it a layer 0 and height 2, let's say. There we go. And then what we can do is, if we go back to Unity and we make a new object, let's call this neural network. Let's go to resources, make a folder called resources, and it must be spelled correctly and have a capital at the start, because it's a very special actual folder that's necessary if you want to do loading objects on runtime. Well, with this kind of system. Then, as you remember, we need to add a folder called prefabs, and let's say our object is just a little, let's say a circle. I think we called this neuron. This is a neuron, yes. So if we just make this a parent actually. So this neuron can have a few different values, but this will be the value part of it. And then we can add a neuron. There we go. And we can make this, actually let's make value a bit smaller. 2. If we just unlock this, make this 1, then lock it, make it 0.2. If we then drag into prefabs folder and delete the neuron, and I recommend making it some crazy color like bright pink or something, because that usually says that it's not being set, and so yeah, that there's something really broken. It's the same as like shaders. If something goes wrong, it's bright pink. And as you see, it's in the right place. If we open our scripts, let's do a bit more testing. So let's just wait for it to load. Okay, if we scroll up, we can add another let's say another few neurons. This will be 0, this will be 1, and that will be 2. And we can even go change the layers. So if we start Unity again, whoops, it does not like that. Let's go back, and there's 10, 11. Okay. So yes, we need to make this neuron 1 and 2. Now if we go back to Unity, and if we press play, there we go. It works about pretty much what I expected. And as you see, we already got a good start. I'm just going to change from wireframe. I don't know why I'm using wireframe here. So we go shaded again. Actually quite a few cool settings like wireframe, shaded wireframe. I'm going to go shaded. So I think the next thing, I try to save it when I was in play mode. The next thing we need to do, I think, is the renderer. So what I'm going to do is I'm going to make a folder, C# script, neuron renderer. Okay, and if we just wait for this to compile and open it, there we go, Neon Renderer. And I'm just going to go in here. I'm going to have a, let's say, let's go. There's actually if we just make this a public float value, and what you can do is to make it so it hides it in the inspector, since we don't need to edit this in inspector, break things. Hide in inspector. There we go. Then I can have a private sprite renderer, and this will be value displayer. And then we can have a public void update. Okay, and it will call a function called render. Okay, let's see if it's clever enough to introduce. No, not that. Damn, I was hoping it'd have. Nope, it does not want to make a new function called renderer. So let's make it myself. Public void render. And if you want this to only happen a few frames, then what you'd want to do is go render, delete it from here, and every time you set the renderer, you set it in your network when you use it. But we don't need to do that since I'm seeing it's on updates. So next what we can do, we can go value, okay, we can go if value displayer or value display. Or actually, let's go is equal to null, and we can go value displayer is equal to transform dot find, and we can we'll input value. We're going to find the parent. I actually never knew this was you're able to do. I thought you had to go dot get child, which you can do, but you have to give it an index, which I don't like very much. And then dot get component, and we're going to give it sprite renderer. There we go, and that's it for the if statement. Next we go have it now. We can go change the value color now, and we're going to make convert a value from -1 to from 0 to 1, I believe. Well, actually, from -1 to 1 to 0 to 1. So the actual color class can read it. So we're going to make a float. There's going to be value color is equal to, we can have in brackets value plus by 1f. And then we're going to go divided by 2f. And that will be our value. So this is just, all we're doing is if it's, let's say it's -1 is our value we're inputting. That will be a 0, and then 0 divided by 2 is 0. And that will be gray. And let's say it's 0.5. Let's say the input is 0. It will become 1, and then 1 divided by 2 is 0.5. And that will be the output of value color. Now if we go float, not float, a value displayer dot color is equal to new color. Okay, and we're going to give it value color, and value color. So the reason why we're doing this, and what's quite cool about this, is let's say you want a value color, you want it to be very, let's say, because just remember RGB, so let's say we want a blue shade, you can just do this. And I'll just save it like this, and I'll show you what it'd look like if you did this. And it has some quite interesting results as I showed in a previous video, showcasing my old system, which was very broken and horrible, but I did use this exact system for coloring mapping. Well, very basic color mapping, I would say, but it does work well. And if you saw in last video, watch the last video, I made it all the colors of deep shade of red. And that was quite interesting, but all I did was put the value color in the R part and the R part, and everything else was 0. So this, everything will be a hectic color or shade of blue. But if I just, that's great, if I just go save everything, I go neural network now, and what I can do is instantiate a neuron. I can go down. I'm going to have a private neuron renderer, and this will be renderer. And when we set this, we're going to go renderer.value is equal to value. And we can then go in here, renderer is equal to neuron object dot get components neuron renderer. And if you really wanted to, you could do some try get component, do some errors, but I know it will be there. And if it isn't, then I want errors so I know exactly what's happening. Right, so if now we've should have done, and it should be a certain color. So if, let's say, we make the first neuron dot value is equal to 0.3 f, may the next is negative 0.7 f, and may the last one is 1 f. Right, so if we press play now, let's go Unity first. And sorry if you see me clicking a bunch of buttons, quite a lot. It's because I have 2 windows open. One on my second monitor, which is my codes, which I must kind of copy a bit. And oh, good gracious, why is it giving us these errors? Okay, let's see what. Oh, of course. We'll just go to Neuron Renderer and go Neuron. Just I was saying a bit earlier that I know it will be on the renderer, neuron renderer will be on here. It isn't. Now let's press play and it should work. And as you see, it's all shades of blue. This is actually quite pretty. I might keep it for a bit. But you can make it way if you want, and you could even, I guess, divide certain values by 2 to make it like pinks or oranges or whatever. So, but yeah, may I make it an orange in the end, we'll see. But it does work well. So if we go neural network again, and let's open it, it's really taking it. It's really a bit irritating because for some reason it opened my Visual Studio Code, but it didn't open it in the wrong window, and I had to move it, and I closed it and opened the script. So it's a bit irritating. I don't like Visual Studio Code much at all. Or for some reason Unity has problems with your Visual Studio Code. It opens like weird wrong lines and errors. It's just weird. But yeah, as you see, it does all work. So if we delete all the code here, so if we, let's just scroll down. So now let's hook up our connector. So I'm going to make a private game object, and we can name this renderer. Actually, why are we making a game object? Let's do a neural renderer, and that can be our renderer. Then I'll add 2 variables. This will be a public neuron, and this will be a start neuron, and I'll have another public neuron, and this will be an end neuron. There we go. Next, I'll make a public connector, and this will be input a neuron. This will be the start neuron and the end neuron. There we go. And what I'll do is go this dot start neuron is equal to start neuron, and I'll do the exact same thing for the end neuron. And we'll also input a float. This is weight. and we'll have this dot weight is equal to weight. Then we'll start initializing. Okay, let's add a comment now, and let's name it initialize, and we will say initialize variables. There we go, it's fine. And then we will go over here. We can add a comment. This will be, let's just go instantiate connector renderer. Set that to the top again. So this will be a line renderer, and I'll show you how to add that in a minute. So what we'll do is we'll have a game object, much the same kind of thing here. So you can even copy and paste the code. This will be a connector object, and connector object. And this will be .getComponent line renderer. So I guess we can make this a line renderer instead of a neuron renderer here. Okay, so next what we're going to do is we are going to actually change from neuron to connector. There we go. And we're going to go and let's go initialize variables, sure. And in here we'll go, and it'll be vaguely similar to the neuron renderer. So what we'll do is we'll go connector object, or even renderer dot, and let's go set position, and we'll set the position index 0 to start neuron dot renderer a dot game object. Okay, and we'll have to make this a renderer public. Okay, renderer dot game object dot transform dot position, and there we go. Then what we'll have to do is we will copy this, and this will be the end neuron. There we go, and this will be setting position 1. Then we'll have a float connector color is equal to weight plus by 1f divided by 2f. There we go. Then I'll go connector. Whoops, not connector. This will be our let's go renderer dot start color. So we'll go start color is equal to new color, and if you want all the different colors, so all the lines also to be let's say a blue, then you can do the exact same system. Just replace this color with something like this and connector color. So just be something like that if you wanted it, let's say blue. Let's see what that looks like. And I think that should be it. And we're only seeing this once, so we don't have to do some irritating like set and get again on the weight. So it should all be fine. So if we run Unity again, well, it did not like that. Let's see, line 81. 81, there we go, semicolon. And the name position does not exist. Let's see, 73. And as you see there, it decided that it was on 81 for some reason, even though Unity says 73. No idea why. But position doesn't exist. Okay, so what we want to do is the connector object is just vector3.0. There we go, not position. Yeah, I'm trying to click on the wrong my Unity on the second screen. Right, now it should all work. Let's see. Oops, of course it won't work. I haven't initialized a connector. So let's have 2 neurons. There's 1 neuron here, and this would be, let's say, start and end. And then we'll have a connector. We don't even need to store the connector. It can just be new connector as new connector. And this will be start, end, and let's say 0.5f. And if we run Unity again, we'll get an error. So obviously I forgot, we need to make a new prefab. This will be a connector prefab, and it will be at position 0, 0, 0, and yes, the new one's also there. It doesn't really matter what position it is since we are writing it, but it's just nice. Then we want to right click on it and create an object again, go effects and line. I think trail is good for like tracks. Let's say you have a tank or something and it's mud, you'd use that for tracks. But I think we're going to make the width 0.5. To see this, let's change in the index 1. Right, that's way too thick, good gracious. So we want something, let's go thinner, thinner. That's nice. I quite like that. So you can even do nice gradients if you wanted, like something like that. I'm not going to do that. I'm just going to do default, just white, because we're going to override it anyway. So let's say 0.1. And we can change the index on the Y, which is the positions. As you remember, when I set position, we want to set that to 0, all on 0. And there we go. So if we go press play, oh wait, let's go. We want to actually, if we just make this connector, this can be the connector. There we go. We don't need this object. We want the line renderer. And now if we press play, we have a nice... It actually looks really pretty with the gradient, but I think something went horribly wrong there. Although that does look quite pretty actually, I like it. Oh, of course, we forgot to set start color. We want to go end color. There we go, now it will work. And we want to press play. And as you see, we have a nice blue line, and it's 0.7. I think it was 0.7. So let's just change these from the blue color, although I do like it. So we want to make it all connector color. And do the same here. And it's our gray again. So let's make sure it all works. I did not like that. Oh yes, it's value color here, not connector color. Keep on forgetting, pressing the wrong Unity. So let's press play. And it's our gray again. Okay, so the next thing we might want to do is, actually what we do kind of want to do is make the connectors. I didn't do this in actual end product, but if we make order in layer 0 on there and neurons are in front. So order in layer is 1. And now all the neurons are on top of the connector. So you can't see the ugly connector piece where it's in front. There we go, that just kind of bugged me a bit. So that is the very first step. However, you may notice that the connectors don't actually have any values. So what we're going to do is we're going to go to start. We're going to go to start of values equal to 0. I don't know, let's say 1. Okay, and we are going to have a public update layers. Oh, there's a void, not a constructor. And this will loop through, and we'll have a for loop, a nice default for loop here. And I'll replace I with layer index. And it will be less than, instead of length, it will be less than layers.count. So layers.count is from here. I'll have a public variable, and this will be a list. Okay, you'll have to add to a list of layers. Okay, layers is equal to new list layer. There we go. And in here we can go have a layer. Let's have it as its own variable, just to shorten our code. Layer is equal to layers in the index of layer index. There we go. I'm going to have a for each loop, just because we don't need a for loop and it's a bit simpler. Neuron, and then instead of item, I'll call it neuron, and a very creative name, and then layer.neurons. There we go. And in here we'll have neuron.value is equal to 0.08. So the reason why I'm doing this is because we want all our neurons. Okay, so the reason why I'm doing this is because all the neurons, if we didn't do this, they would keep on adding up and it would be incorrect the next frame. So I'm also going to add a few new layers. So I'm going to have a let's go layers.add range. Okay, and I think it's something like this. Let's just check in my second code. Yes, it's, oh, there we go. I have a nice feature actually that I enabled in Visual Studio Code, because every time you see that it actually formats my code when I save it. Sometimes it's quite irritating, but it's generally quite useful since it helps you figure out if there's a bug in your code, because generally formatting breaks if that happens. But I'm going to have a layer, and I'm going to add an input layer, and we have is equal to new layer, and another layer, and this is our outputs layer. And these are all, by the way, these are all temporary layers. These will be changed a bit. Because obviously we have 100 lines of initialization code. And that's going, and I think for that I'll just give you like maybe a paste bin or maybe a Git project, which you can just copy all the input code, because that is painful to write, trust me. First time I tried to write it, and yeah, it was horrific. But we're going to add the two layers here. We're going to go input layer and output layer. Remember, don't add a comma on the last element in here, because otherwise it'll cause errors, formatting errors and all sorts. So I'm going to go layers is equal to new list layers. I actually got it a bit wrong. There we go. And what we can do is we can go in the end here, input layer dot neurons dot add range. Okay, and then the add range, we're going to go new neuron array, and then we'll have something like this. There we go, and we'll have input layer, and that'll be the only element in here. We don't really need an add range, but it'll be easier later to just add it, because we'll have lots of neurons added here. We need to add a few other things actually. So we'll have an update layer, not update layers. Layer, is it clever enough? Nope, it definitely isn't. Let's go public void update. I think there's some add-on that lets you generate functions like this. Just generates this code, this part. But for some reason it doesn't let you by default, I'm not sure why. But it's going to input a few things. It's going to input the layer and the layer index. Okay. Actually, we don't really need the layer index in here. I think, yeah, there might have been some old code that I later removed. Let's go input layer, and it inputs layer. We can go for each, and we're going to go for each layer in layers. Well, actually, for each neuron in neurons in layer.neurons. There we go. We're going to have a float. This will be the sum 0.0f. And we can have for each connector attached connector. So for every connector attached to our neuron, and by the way, I did a bit wrong, we're going to start from index 1. So this because I had a bug where input, I think I explained it a bit in the start of this video, the intro, but layer index, it is actually the input layers. They can, or any layers that before it, they can connect to wherever they want. So they don't all directly connect to the neuron we're checking. And that was a huge problem. So instead we're checking a layer ahead and getting all the connectors that are connected to it. So I'll show you, hopefully you understand a bit better if my explanation wasn't good enough in code. So if connector, not item, connector in neuron.connections. So if connector dot end neuron is equal to neuron. The reason why we're doing this is to make sure that the connector is connecting from something else to us and not from us to something else. And what's nice is this in that kind of accidentally did this. I didn't know it would cause this great side effect, but in this we don't reset the neuron, the input layer neurons, which is really nice. It just removes an if statement. It isn't too much, but it's just quite nice. We can then go sum plus equals by connector dot weight times by connector dot start neuron dot value. So this is actually the final code for this. We're never going to touch this function again probably. We're going to go neuron dot value. At least in this course I'm not going to touch it again, because this is the final code and it should all work for everything else. Let's see if it works here. So it should start at 1F, that's the input neuron, and if we run it, oh, it did not like that, 33. Let's find number 33, output layer. Oh, this was supposed to be neurons. Okay, I did this a bit wrong. We're going to input start and end. This pretty much, apart from this, yeah, this is all we need to do to initialize your network. So in reality though, you'd want every neuron connected to every other neuron in the next layer. But for me, I don't really want that. It's just, for this project, it's just a bit easier to do it like this. But if you're making a proper neural network, you might want to do it differently. Right, okay, I figured out what was wrong. Turns out it's a bit silly. I totally forgot to call update function. So there's supposed to be void update. I've totally forgot to call update layers. I don't know why, but you're supposed to call an update. But now if we press play, what? It still doesn't work. Good gracious, what on earth is wrong? Okay, I figured out exactly what was wrong. So in our set, there are two values. There's our value here, and there's a special value that was generated by the set, which is the value that it's trying to set. So I accidentally set, I think, value to value. So instead you must go this dot value. That will work then. And also another thing, you must go start neuron.connections.add and add this, which is this instance of the class. And do the same for the end neuron, just so they know you exist. Otherwise, they don't know the connection exists at all. And because they loop through here, the connection which is from the neuron, it won't work. But now, if we go back to Unity, press play, as you see it works. We can even add another connection. How about let's add a new variable. Let's go start2 and start2.value is equal to -1. Let's have a 2-pixel display. Wow, that's quite a camera, isn't it? And in the end, that's fine, we can leave end. And just to show you how easy it is to do this, just add start2 and just add another connection, and that should be it. I'm going to make this weight 1. Or let's say, yeah, just 1 for now. Make it simple. This means that if we calculate it, so 1 times 1 is equal to 1, and then plus by, well, they're on the same. It does work though, it is correct. We just want to make this 2, let's say. So the reason why I'm saying 2 is not 1 is because before it was 1, but I made all the increments smaller so that the neurons, the neurons at the very end could stack up nicely. So a single piece should be 2. A single one of these segments should be 2 increments. And as you see, 1 times by 1 is equal to 1. So this is white. And then but it's not white because we have negative 1 times by 1 is equal to 1. And we're plussing those together. And of course, 1 plus by negative 1 is equal to 0. And that's pretty much how neural networking works, actually. I'm just going to copy my entire start method from my my original game, because I'm not writing all this, every single initialization of it. And if we paste it in, I'll give you a paste bin, maybe you'll get a GitLab link to the full project. Okay, it didn't quite work, so I forgot. We need to do one more thing on the neuron. I think it's only one more thing. Yeah, pretty much one more thing. It's a Boolean, and this Boolean will be called use ReLU. I'm pretty sure that's how you spell it with the lowercase e. But it's just another clamping variation of the clamp, except what happens is we can make this a private Boolean use ReLU, and we don't have to change any other code. What's nice is it's so segmented, and I love that with code. It's so dynamic, segmented. You only have to change one part of the code. That's why I love Get and Set. I only recently started using it, and I've fallen in love with Get and Set. I've used it every project now. And also, I've always misunderstood the special if statement, which uses only one line. I love it as well. All you do is have a question mark, and then you can go 0 if it's true, and then if it's false, it will be negative 1 if. Okay, and we can copy this, and that will be the output as well. Right, that should be it. If we test it now, okay, it did not like that. Let's see. Oh yes, I forgot again. Use ReLU. If you remember, if you watched the intro of this, I don't know if you skipped or not, then we can say to true as a default value false. As a default value if you don't want to have to say it in every single one. So you can only set it to true when you need it. And otherwise it just makes the code a bit smaller. But we are done actually. So there, as you see here, it is I think there's one little bug, I'm not sure, but it doesn't seem to say it's anything. I'm not sure why. Okay, I just figured it out. So I was terrified for quite a few minutes, terrifying that I got the whole thing wrong and I'd have to restart everything, but no, thank goodness. Turns out it was just as simple as forgetting to set a value. So I was supposed to set this dot use ReLU is equal to use ReLU. I don't know if I'm pronouncing that, actually thinking about it right. But if we press play, right, let's see if this works now. Oh, by the way, I did one more change. I'll just show you now. So what I did is I added a public float in 1, in 2, in 3, and 4. This would be all your inputs. I don't know if there's a hacky way of doing it or not. Maybe if you think it's hacky, you can change it. And it has a range between negative 1if and 1if to make it a slider. So you can't get too big values. And in update, I have a list of neurons in the first layer, the input neurons. And I'm going input 0, 1, 2, and 3, which is all 4 values, and we're setting them. just before update layers. I did this after at one point, for some reason, I don't know why. And the whole thing, it took 2 frames for it to get correct, because it only updated the values on the 2nd frame, which was very irritating, so I changed that. But now we have nice clean input neurons, well, ins, and you can change this now. So if we make this -1, and one weird little, just weird thing about this neural network, it isn't wrong, but if it's not one of the horizontal, vertical, diagonal, or solid, I think is up here, then it will say it's solid, vertical, horizontal, and everything else. So actually, one more thing before I'll just show you what it looks like though. If we make this, there we go, make these 1. As you see, it says it's horizontal. Let's say we make it go, let's say we want it to go vertical. This goes vertical. And you can invert it because of our inverters here, these inverters. It just flips it, so it still thinks it's vertical. Now, one last thing I want to do before I end off the video here is I'm going to make a new empty, or not an empty, sorry. Go UI, Text Mesh Pro, import TMP Essentials. Now, you don't need to do this, by the way. You can stop the video right now. But this is kind of important just for what I want to do. I'm just going to make a run it. And I'm going to go to our text, and I'm going to move it right, let's say here, and we can make it black so we can see it, and increase the font size quite a bit. Just make it bigger as well. And we can name it solid. Wait, solid. There we go. We can then go vertical. Vertical. And then we have diagonal. Okay, this is diagonal. And finally, horizontal. Right, I'm just going to copy all these texts because they'll undo, and we can paste them in the canvas again, and drag them to canvas, and now we have just little text just to show us. So if we press play now, our neural network is generated, and obviously you can change these values on update, and this would be the inputs of your 4x4 pixel grid. So let's say we want it solid. Let's make it solid, but it's sort of solid. Like, I'm not really trying. I'm kind of just barely making it solid. But as you see, it still thinks it's solid. Even though it is starting to think it's diagonal and horizontal, it still thinks it's 100% solid. So, actually, before I end the video, I forgot to do something. All you're going to do is go make the neuron and go make it bigger. And I'm going to add a text. This is just a kind of debuggy thing, just to kind of show you what it'd be like. Let's make the text really small. So let's say, I don't know, 5x5. And let's find our text. Let's go to the canvas, and we can make it 0 and 0. And if we zoom in, let's go auto size, and min is 0. And we can make this tiny text, and it will really squash it down. Make sure it's in front of the value so we can see. I'm not sure why we can't see it actually, that's weird. I'll just try and figure out quickly. I'm just checking my second screen what on earth is wrong. Let's go to our canvas, and let's see, ordering layer, yes. Okay, just change the ordering layer to 2, let's say. And we can make this value text, And if we go over to our script one last time, and we go over, okay, so what we're going to do is we're going to make using TMP Row Text Mesh Pro, and we're going to have a public, just do this really quickly, TMP underscore text, and this will be value text. And on here we can just, this might be a bit of a hacky way of doing it, but I don't really care right now. Just set to value.text is equal to value.toString, and the formatting I want a 0 and put in a string 0.0. And that's how it's going to format it. Maybe you want more precision, then you can add multiple zeros. I don't really care too much about precision. That's fine. So if we go back here, and I'm just thinking now we won't be able to see the text. Oh, that's weird. What on earth did I do there? So what we can do is make it some crazy color that we can see. Let's say red. And on the neuron, set the value text. Right, that's perfect. Now if we press play, as you see, it's a bit weirdly placed, but it all works. So here it thinks it's solid and horizontal, so let's make it more solid, I think. As you see, it says it's solid. If we make it vertical, it will say it's vertical. If we make it kind of weird, really quite hard to see vertical, would still say it's vertical. Yes, it still thinks it's 100% vertical, but also starting to think it's solid, which I can understand. It does look quite solid here. But yeah, this is the end of the video. I have all the links to the previous intro video, and the Git page for all of the code. So I'll see you next video. And if you have any videos you want to see, then please write the video idea down in the comments. And I'll see you next video. Bye!